Teste. Hello, my name is João Nascimento. I'm a master degree student from Montana Tech in Butte, Montana. I'm studying environmental restoration management, and I would like to show my graduate projects, which is aimed to solve a real-world issue. Uh, it's a restoration management system. It's a database and software tool to consolidate and store and manage all information regarding restoration projects. And I have this idea because after studying working for restoration, I can see many research focus on plant adaptation, plant biology, mycorrhizae, and which plant is the best fit for which soil, if each contaminants, and bioaccumulation. Many studies like that, which are very useful, wonderful, and really good. But I can't find really many studies focus on achievements and efficiency of environmental restoration projects. I understand that these projects may last years, maybe decades, but then I have the idea to build a tool to help data management and administrative issues of restoration projects. So it has some features, as you can see here on these buttons, and they came from project specification I made in the very beginning, what that describe what a restoration database should have, what task management usually we do in restoration projects. So I made a tool to help us share information and build reports, data analysis, and store monitoring data in a source. Usually what you see, it happens in every company. We have many employees working different computers. Sometimes they're not in a network, and people save their own files, their own folders under a passwords. And when time comes to issue reports, so we have to find where the data is, and if sometimes people retire, they leave, they're on vacations, and it's always good to keep all the information together in a single source so we can access it when needed without any restriction. Of course, we may add here some passwords if needed, but the idea is make information for projects easy to access for everyone who will work. And so we have here area, one of the features like area management, if you break down by project, site, section, map visualization, budgeting like resource allocation with labor, tools, fuel, plants, planning supplies allocated for every site, site maintenance, task scheduling, and resource allocation, plant inventory management, so we can manage the plant batches for to be planted restoration projects in a greenhouse and manage them by year, by plant species. So some states require use that local, native plants from local sources be used in restoration projects because they are better adapted for the local environment and soil conditions and weather. So it's expected to have a better surviving rate. So on how can we prove and demonstrate that those plants are really local? So this system allows the user to track down the seed collection locations, the seed bags or cuttings to a plant patch in a greenhouse, and then know where those plants were planted in the site. So we can track since the seed collect location, the seed bag, and know, these plants allocated for this site, they came from the seed collect location XYZ nearby. We can track this and choose every year if you use different sources to plant the same site, and like making a mix to add some genetic diversity, even using local plant species. We have also online remote access for field work. This also have internet access. We may use this system notebook in the fields and access the central database. We may store monitoring data, site monitoring data with different forms or monitoring parameters, plot graphs, and gets ready instant statistics for them. Have also seed mix calculator for grass and forbs. We have a plant database with the plants concerning that are important for the restoration projects managed by the users, and cut tests. You can store data for cut tests, stratification tests, record seed collection locations, and also manage the seed inventory, seed stock with independent bags. And I believe that restoration projects, they face many challenges. For example, funding is one, unpredictable weather, unknown biological and chemical factors for every site. Every site is different than others. They have different contaminants, different plants, different soil, different story, different sun incidents, different stressors. So every site is different, and it's hard to determine. There's not a pattern to follow. We have a lot of uncertainty about how ecosystem will develop. So all these issues work against the restoration process and the plant and ideal environment restoration. So it's good so we can keep control of what's under our control, so we can reduce the uncertainties that we can't really. Let's just keep the uncertainties we can't manage, because those we can manage, we can keep track of them and do our best. And when our system can reduce mistakes, focus energy, manage resources properly, and reduce waste. Cost efficiency is a goal also for restoration. And it's not, when we talk money for restoration, money is not against environmental restoration, we may think, but actually money and cost issues is a goal today, because more saving means more doing, just like the hardware store saying. And we can do better restoration with less funds, and that means also more public support and more funding. So the wheel start to spin in favor of restoration works. Okay, and this is how I think we could help the real success rate of restoration projects everywhere. In this case, let's start here on the project site section management. So every restoration project, and this software can manage different projects simultaneously. So every restoration project is made of sections made of sites, and every site may have different sections. So I'll show you a diagram that helps illustrate this concept. So in a project, maybe like a big project like environmental restoration of a large area, and we may have different sites apart from each other. So site 1, site 2, site 3, and every site, depending on their size, they may have different sections for it. In every section, why they can be different. We can have different soil characteristics, different sun incidence, different plants, plants that already exist in the site, either desirable or undesirable or noxious or invasive. So every section may have different erosion issues. So if we can have a good breakdown, we may help focus focus the restoration force, knowing what should be done every site, and keep like cost control and budgeting for every site individually, and know how much was spent in sections. So it's also a good idea to have this breakdown. But of course, you may have a single project with a single site with a single section. The system is okay for that too. So going back, so let's start this project, site section management. Here we can have create new projects, new sites, or new sections. To create a section, first we need to have a site, and to create a site we need a project. I'll show the create project screen. We'll have names here like fields like name, sponsor, starting date, end date, objective, and so on. But I'll show you, to save time, projects that we already have registered in the system. They are test data. Though these are not real data, but they are data that could be real. So I have to make the system work and test if some data that could be, close to what you find in reality, to make features work. And then I add here some data. So this is a restoration project info. We have a code. This code is auto-numbered by the system. Every project has an individual ID here, and the user can write the name, sponsors, starting date and ending date. I have this date picker and objective for the site. We may have a manager, developer, and the funding. We may search by either project name or manager if I have many. Let's say I'll show you here, like Anaconda. Don't need to type everything, just a part of it. So say Anaconda Smelter Restoration Project. So we can search projects under the project name or the manager. Also have the project. We may see the sites. I'll show you one site here. I'd say build native plants, and this is a project. I'll search sites under that project. Clicking there, we see here a site screen. You can see the site codes, the name, site name, the project for which the site belongs to, the address, city, states, zip code, landowner, latitude and longitude, attachments, and hyperlink. So this is a Bing map. Once you type the latitude and longitude here, it brings the satellite photo for this latitude and longitude that we recorded in the site. I'll show you here. If you slightly change the coordinates, the map will change to the north, and just reduce the zoom. Here you see, here's Butte. We were actually close here, and then it will move far north because of the change here, and the longitude. So here in attachments, we can double click. First, we can make copy and paste the link for the attachment, and the attachment may have like any Word, Excel, PDF, or other formats, file types for documents related to that site. In this case, there's a PDF example. I opened it for you to see. So we may have reports and historical information for the site. And here in the hyperlink also can take us for a internet address or for a PDF document or Word documents. So here we see the site restoration. The hyperlink for it may have a preview, may scroll down, or clicking here, it will open the file for us. See? So instead of looking for files and reports everywhere, once the employee has access to this database, he can instantly find the information they need and access it for planning their work, making reports, studying a problem. Though I think it's a very useful tool. And the budget. First here there's more sites. I can show like Montana Trail. This is means that it's trying to find a file that's not here. So it's always good to keep the file in the same spot. Not a problem. Then I will show you the budget. This site. I show you a site which I know there is a budget for it. So the site belongs to this project, and okay, these are different sites for different projects, and here have the same information. And that I'll show you. The attachment could be also a photo. Could be any type of documents you want, provided of course you have the software to open it here in your computer. So it could be a photo of the site. And here is the budget. Okay, to have a budget number for the site with the grand total and the budgets. Actually, it is in this screen you can only see the budgets, but you can't change it. We can assign resources and make a budget on a different screen. I'll show you in the next videos. But here you can see a budget that was assigned for that site, and here you can like find tools like spades, auger, plants, and planting supplies, labor, consumables, everything that is supposed to be used in the site, and the cost per unit, the quantity, total, and the type of item. So you can here have a breakdown of your costs and total costs, and I'll show you later where these resources are configured. We can configure resources and find the costs. Actually, it could be the real cost, not only the tag price, because we know that sometimes, especially for labor, have extra costs that's not really the amount paid to the employee, and the quantity, so it multiplies. And here we have the grand total, so we can keep track of what the budgets we are using the site. Okay, and once you have a site may have different sections. So here you can see if I select a site, you can create a new section for these sites or search sections inside that site. So I'll show you different. Here's a section screen where I have like project, site name. This is the section name, landowner, address, CD, everything else as before. I may copy, or they may be different. For example, a site may have a section which access is from one street, and a different section can only be accessed for different roads. It depends on, what we find in real world. So to have the latitude, longitude, total area that we will find use for that later, and climate zone, it's for the plant hardness map. So here that means that the lowest temperature it's expected to find the site. Here's the Köppen-Geiger climate classification for meteorology specialists. We can have like the acronym, and here the description of Köppen-Geiger climate classification for the section. Soil, data, and comments. These comments are all information that the user finds to be useful for the restoration for that section. Could be capping soil, brought from Bozeman, vegetation-free invasives like alfalfa, baby's breath, or knapweed. Could be dogs or restrict access private lands, get the gate keys with someone before entering, or warn, or like bears and wildlife around, so any comments that could be useful for work. And here in another tab, land info, we may have a KMZ map. It's a Google Earth link. If you also using Google Earth, it's a free tool even for the professional version. We'll have the KMZ file, so we can save the KMZ file for the database, and it should open up now. I will uncheck those boxes to make it load faster. Of course, depends on your network and how fast your computer. Usually it's faster than this. And then once you are on the screen and click the KMZ link, we can go quickly for the section. So this should be the whole site here, whole restoration site, and this is a section of the restoration site. So we have this turquoise and light blue-green shaded area, which is a section. Discard, change, cancel, continue, yes. So just asking if I would like to save or not, so I clicked no. So that's soil status, photos before. Okay, may here add a link for a photo or for a file or for a folder with many photos for the site before, during project, and after the project for documentation. Usually, sometimes these photos can be lost, but once they have here the link in the system, they won't be lost anymore. Planning map. Well, the planning map is useful when doing maintenance, site maintenance, because for small plants or forests, very, very easy to mow them by mistake when doing weed whacking, and these plants are expensive to be planted, so we should save them as much as possible. But we know that sometimes when with the weed whacker or weed eater, we may cut them by mistake. I did it sometimes. So I think that it should be useful to have a planning map for every section. Could be like a sketch, even hand-drawn sketch, doesn't need to be anything fancy. So when you go into the site, we have an idea where the plants are located, and when coming closer to those spots, just be more careful. I think it's a good idea. And wildlife is all wildlife exists in the section. Could be birds, insects, or some other animals that are of concern for restoration works, like elk, deer, beavers, and frogs, maybe birds, or some bugs, infestation, because it actually is all the wildlife that's the user or the restoration worker should take care when doing restoration on this site. And fish, well, sometimes there is no water stream nearby, but in some sites you may have a river or water stream or a creek in the site, and depending on the river classification, stream classification, and the fish that live in it, we may be concerned about spraying. Some herbicides may be harmful for fish, and when doing moving soil and planting, we may take extra care when live for about soil runoff, and live in bare soil, because if there's some runoff, may harm the fish. So we may want to register here any fish that may be affected for the restoration works in this site. Here's a baseline plant list. we have here different plant species for the database. We may click here different species and they will show up in this box to easy visualization. And there's a baseline plant list. I mean the plants we found in the sites before restoration starts. Okay, and they are saved in the database. Here's a seed mix tab. So for plain, sometimes seed mixes are spread over sites which contains like grass seeds and forb seeds. So there's a different screen I'll show you in the next videos where I can show the seed mixes, where they are created and can calculate the percentage and the seeds per kilogram, or how many kilograms should be applied over a section area. I'll show the next videos, but this one can have we can see the seed mix that were applied for every site, every section, the area applied, and weight used, and the sowing dates. Okay, so onset restoration works may last for years on the same site. It can be expected seed mixes are applied over and over and over, so here we can keep track of what is used for every site and when and with quantity. Now, of course, the percentage of seeds in the mix. The next step is minerals, contaminants of concern. Should here have substance of concern. When it means of concern doesn't mean there are too much. Could also lack of that substance, like nitrogen. So clicking this drop down, we may have the concentration of nitrogen, which is nutrients. So we may type here the concentration, or the contaminants, like for this case pentachlorophenol, and the concentration in milligrams per kilogram as found on the laboratory assays. So here's calcium. The database comes with a list of contaminant and substance, and the user can add more when needed. Okay, this is area management. These are area management screens. Next videos I'll start with resource configuration, plant species. Okay, thank you. See you.